Now if any kind of questions we have, for example this a value which I don't know right now, this is what we ask from the user using cout. We give cout and then we ask. Don't go with the handwriting. So in this type of suppose a person gave here 12, so the value will impact the for loop and it is dependent as algebra. You can see this for loop will go from right to 1 2 3 4 5 6 7 8 9 10 10 11 and then 12, and it's a plus manner. Okay, now this is the value of x. These all values right here are x. These are x. Now the question here, a which is 12 constantly sitting and the x value is 1 to 12. Now if somebody asks you which are the numbers will divide 12, so we can clearly tell it is 1, 2 will divide, 3 will divide, 4 will divide, 6 and 12. This many numbers are going to divide 12. So if we write here instead of 1, if we write here x, just x, then the values all this we have will be added and it will sum up to 28. That will be your answer. This one, this is your answer. But you see the question, I did not write here x, I wrote 1. So if you write 1, what will happen? Instead of these all values, instead of writing the values of x, it will take 1 every time. So it will take like this. So 1 1 1 1 1. So these are the, if you take x, this will be the values, these all. But if you write 1, so instead of taking all this, they will take 1 1 1 1 1 1, and this time the total will come as 6. Okay, so remember the difference. If you write here x, then these all will be added. If you write 1, these all will be added, so it is coming as 6. So similarly, if I change the value right here, as if I change it to suppose 15, so you know which all will be divided by 15. So this will be 15 once again, 15 divided by 1 to 15. Which are the numbers? So you know it will be 1 3 5 and 15. But as because there is 1, so it will come 1 1 1 1 4 times. This is 1, this is 3, this is 5 and this is 15, and the result answer will be 4. But if you give here prime numbers, like if you change this number and give like 11, if you write 11, you will see your answer will just come 2. Why? Because 1 and 11 itself will divide and the addition will be 2. Similarly, if you give 13, again it will give 1 and 13, and which will be 2. If you give 19, again 1 and 19. So you know all prime numbers are divided by 1 and the number itself. So as a result, their sum will always come 2. So at last, if you just write here that if my sum s, which if double comes 2, it's a prime number. So we'll test it right now in our Turbo C++. Okay, if we go to Turbo C++ and try to open it, what fine. And we have a, and we are taking for the counting s equals to 0. Now first of all, we'll ask the question to the user that enter the number please. See, so good, and then close, and then followed by we'll take the number, and then for detecting prime, what you can do is for x equals to, so suppose if you forgot to write it here, Okay, you just write it here, x which is required. So we'll go back here and write x equals to 1, x less than equals to a, and x plus plus as I showed you, same way. And then a tab here you'll write, it looks beautiful. If a modulus x double equals to 0, then your counting is s equals to s plus 1, as I said, and then you have to just close it. And at last you'll write if my s is 2, so my answer will be, it's a prime number, so it's prime, okay. And else I'll write that C out not prime. I can write composite, whatever you like, and then I'll have a get ch followed by ending close. Now program, if we just control F9, see the question, enter the number please. Suppose I enter 12, it will tell it's not prime. Now if I give the number as 11, it will tell it's prime. Any other prime number, like if you give here 13, prime. Now if somebody thinks 9 is prime, 9 is not prime because it is divisible by 1, 3 and 9, so 3 times it is dividing, so it's, if you give 9, it shows not prime. Hopefully all of you understood how to work with prime numbers. Thank you.